Okay. So this is a talk about the new features coming out in Python 3.13. This is actually almost a bit of a tradition at this point because this started back in Python 3.8 at PyHep 20 uh, PyHep 2019, I believe. We had PyHep was in October that year, and it was like within a couple of days of the Python 3.8 release. So I gave a talk there. And that's actually when I started this blog post series that is still going. If you go to my website, isinumpy.dev, I have a blog post on, um, I think I did Python 3.7 um, after 3.8, but then I've done all of the Python versions since then up to 3.13. So as a quick reminder, Python is now released every October. It has a 5-year support window, so every October a new release comes out and an old release goes past end of life. And then the scientific Python community has decided on a agreement they call Spec Zero, which says that for the scientific community, they will only support Python for 3 years, which is why most scientific Python libraries have dropped support already for these first two uh, versions in this list, and 3.10 will actually be dropped this year. Um, and but the nice thing about this standard is that it's really easy to remember where things lie here. A quick reminder for a few of the features that have come out in past versions. If you're not using 3.10 yet, the pattern matching is the big thing there. It's really nice where you have this sort of structure where you can just say match, and then you can match not just on a value, but also on a variety of different things. In this case, it's matching on the class int, um, along with the type unions, which many of us are already using just because we put the from future import annotations at the top. And this is probably the one that had the biggest jump forward in error reporting. Python 3.11 is the fastest version of Python. It was like 25% faster than 3.10. And in my testing, it still tends to be the fastest version of Python. The 3.12 didn't make a huge jump forward as it's largely getting ready for future things. And same thing with 3.13, as you'll see in a little bit. It had these exception groups, which are really nice, where it actually gives you this standard way to throw multiple exceptions. The reason this was added was for um, the multi-threading type exceptions, but this can also be, say, if you're reading a file and there's a mistake, but you can keep going and you can read the rest of the file and collect several mistakes. So you can report them all at once. It's really nice for reading things like a JSON file or something. And it gives you a standard way to do that. And this is backported. They can't use this nice syntax. It also has notes, which are really nice. That's you can add a note to an exception. We've wanted that, and we've basically been trying to do that for a long time. But that adds this in as a feature. And if you're in the packaging area like I am, then you might be excited about this built-in TOML support, and it also has these annotated tracebacks. So I'll show you an example of that later when we see 3.13. And then 3.12 added a few more things, including one that was interesting here, this per interpreter GIL, but it wasn't actually very usable. So we'll see in 3.13, there's actually a way to use it. Um, but it also partially supported perf. 3.13 will finish that and will fully support both methods that perf uses. Perf is the Linux profiler. Um, and F strings are now part of the language, so you can put same type of quotes inside, for example. Um, and it also had these typing generics. So this is an example of a typing generic. We'll see the syntax in a couple minutes. But where you can just do bracket after a function name, and this will become a generic just like a template in C++. You can even constrain that to something, say, like the real numbers, and then um, have an in and out. Use it in your inputs or outputs. Okay, so Python 3.13 is the most forward-thinking version of Python ever, and you'll see why I make that statement in a couple of minutes. There's a collection of major new features. Many of them are ones that you will not really be able to take good advantage of until future versions of Python. So we have a new REPL. This is for the first time in 30 years. The REPL has been rewritten, and it's now in Python. We have static typing updates as usual. There is actually a JIT compiler in Python 3.13. It's the first version with a JIT compiler in the traditional sense, the sense that we think of JIT compiler that's supposed to make things faster. And currently it only makes things a little bit slower. So that will become very interesting in the future. And then there's this rethreading, which we'll talk about quite a bit. And then a variety of smaller features, which we'll also talk about. So first, let's go over the new REPL. This is the first thing you see when you start up Python. So let's just start up Python. So if you just start up classic Python, let's say 3.12, this is what the REPL looks like. And if I get a trace back, it looks like that. And then if I just exit, type quit. Oh, I have to type quit parentheses. Even though Python knew exactly what I meant, I still have to type quit parentheses. Now, if I jump into Python 3, 13. So I have the third beta here. You'll immediately notice a difference. This is now in color. So the very first thing, I think the way that people will recognize Python 3.13 is by this color here. And there's actually color in several places. So if I look at a traceback, you'll actually see several things have changed. I get a traceback. It's now in color, so I have nice color for some of these parts. But you'll also notice, besides the fact that before it just said file standard in a module, but it wasn't able to show me anything about that because it doesn't store this. This was just typed into the REPL. Now it actually keeps the REPL similar to IPython. It keeps the REPL code around, and it can show me the actual error right here. So even if you make an error in your REPL, you still get to see it. And this little part here is the annotations I was talking about on tracebacks earlier that they added in 3.11 or 12. I forgot which now. And now I'm just going to quit. And I have quit. You'll notice it didn't ask me to add the parentheses. It just quit because I asked to quit. So this is the new REPL. It's written in Python. It's more colorful. And there's quite a few things. I'm going to jump back into it. Quite a few new things too. For example, if I were to type def f and x or print hi, you'll notice the multi-line input worked just fine there. It automatically indented and things like that. And then if I push up arrow, you'll see I can get I have the old the entire old thing that I typed in is just here on the REPL. I don't have to do it line by line like I used to. It actually supports multi-line inputs, which is really, really nice. There are also several new modes. For example, let's say I was going to do div mod. I don't think it actually takes but you can push F1 and that enters the help mode. So I could say, what's the help for div mod? It looks like that. And I can just type Q there or quit. And that's also in color. All of the REPLs in Python have this little color on them. And then I can also push F2. Oops. And that's the history view. So I can look through my history. And I can also push F3. And that will move me into paste mode. And in paste mode, I can paste code and it will be nicely formatted and all that. It won't mess with it won't try to add indentation and stuff. It knows that I'm trying to paste. Okay, I can exit that too. Okay. So that's the new REPL. Um, Let me go back here. So color prompt, multi-line input, um, help exit and quit commands are actual commands that you don't need parentheses, and help mode, history mode, and paste mode. You can disable it if you want, but there's not much reason to. And it does, so it even supports Windows now. They've got it working in lots of different places. They have already had a lot of contributors. One of the biggest things about this is that it's much easier to contribute to, and it's not tied deeply to the Python internals. So this is actually something that will hopefully get better as time goes on. They don't plan to make it quite full IPython, but they're definitely supportive of some new additional features. Full like color syntax highlighting might be a little overkill. So and there's the color exceptions that we saw a minute ago. This is true for anything, not just the REPL. There's now colored exceptions, even if you just see this from your scripts. And it's controlled by the force color, no color variables. There are some new error messages as well. So for if you mistype a keyword now, a lot of things, and over the last couple of versions of Python, I've had these fuzzy matches where it tries to see if there's something similar. And keywords now have that too. So it'll say, print got an unexpected keyword argument indel. Did you mean end? And attributes also have from global or installed modules will actually it'll actually give you a message if this overwrites a global or installed module. So here I just make an empty file pathlib. I run import pathlib.path, and I get this attribute error saying that, oh, there's no attribute path, but it explains why. There's a file that has the same name as the standard library module pathlib, and the import system gives it precedence. So this is something that occasionally happens. It's really nice to have a much better description here. It currently only works on this syntax, the attribute error. It doesn't do anything with the it doesn't do anything if you do it from pathlib import path. At the moment, it doesn't affect that one. There's also new typing features pretty much in every version of Python. And these usually are backported into typing extensions, so you can use them a lot sooner. So type is new. Type guard was added pretty recently, and with the type guard, that's a way of saying that this is returning a bool. Type guard is a bool that will only be true if this is a string. However, it wasn't complete. So if you say if not this, then it still says int or string. So it doesn't know that this thing is only a string, that this will always return true if it's a string. So that's what type is does. So type is says, all right, this behaves similar to type guard, except it also narrows it out. So this is a string, and if it's not true, it will guaranteed to be not a string. So that's type is. It's not. Then there are also these defaults. Remember, we saw generics syntax before. There's now generics defaults. So you can say t equals int, like that. And now if you don't give it the template parameter, for C++ syntax, if you don't give it the generics, it will be an int. Okay. There's a very common thing that this is extremely useful for, and that is generator. Generator, if you have a function, those are actually generators, not iterators. You could say iterator, but generator is the more correct return type. However, since you're not doing the fancy stuff of a generator and it's just an iterator, then these two things are none. Well, now those are defaults, and now you can just say generator int and ignore the fact that there's none at the end. So this would require Python 3.13. This is something that's related to typing features, even though it's been added to a different module. So there's now a deprecated. We're already starting to use this. I would recommend using this everywhere that you need deprecated functionality. But there's a new warnings.deprecated. There is a backport in typing extension, so you can use it today. Warnings.deprecated. So this actually is a runtime deprecation message, and you can control what error or what warning it shows. But it also is recognized by the type system. So your type checker can tell you, hey, you're using a deprecated function. So that is very, very nice. Along the same lines, there's actually now a deprecated parameter for the argparse too. So you can have deprecated arguments. A couple other typing features. There's a new protocol, some new protocol functions. This get protocol members, which will, in this case, will return, it's actually a frozen set of X and Y. And is protocol. And there's actually some new internal stuff that's being stored in classes that makes this work, which you can also take advantage of if you're developing strange things. And is protocol will tell you if this is a protocol or not. And there's also the idea of a read-only dict item. So you can now mark a typed dict item as read-only, and then the type system will not let you write to it. Okay. And of course, there is a JIT now in Python. It's disabled by default. You have to compile it. You have to turn on a compile time option. It's a copy and patch implementation using LLVM, which means it needs LLVM at compile time. But once you've compiled Python, it's already generated the machine code for all of the JIT instructions that it knows about, and then it doesn't need LLVM anymore. So you can still build Python with GCC, but you need LLVM in order to generate the copy and patch JIT pieces. Unfortunately, it's currently only a bit slower. This is pretty exciting because the JIT does not do very much. There are not very many of these routines added yet. And but the way that it's implemented, it's only a tiny bit slower. And that's good because you don't want to pay a large overhead for that. And then, of course, as more routines are added, it should become much faster, hopefully. And it will be enabled by default once it's, I think they said 10% faster is their sort of point which they will consider it okay to enable it by default. This could be as early as 3.14. So that's something that's coming up. Also, there is now, so this was added in 3.12, this per interpreter GIL. So you can start up multiple interpreters in the same process, and then each of them will have their own GIL. It's kind of, it was really hard to use in 3.12. It required CAPI. There was supposed to be a package that would let you do this, but that package did not, was never really finished. It had issues. It was using internal stuff of CPython. 3.13 will actually have the very first-party PyPI package. So a PyPI package from the CPython devs themselves, and considered a sort of a first-party PyPI package for interpreters. So they've added the compiled bits into CPython, and so there's a private interpreters API, and then this Python package will use that private API. And then there are some other features. So just a few of these cores for process. This is something that if you ever wanted to ask how many cores are available, what you really want usually is how many cores are available for your current process, and now that's available. Anywhere you see CPU count, there's no process CPU count. Glob.translate will take a shell style glob and turn it into a regex. Math.fma is fuse multiply add, which is probably not a big performance deal for Python because you probably don't care about performance on that level, but it does avoid intermediate precision loss. So that is a reason to do it, and it might be something that would even be useful in some other areas, like maybe doing it explicitly in Numba would be interesting in the future. The PR only took 7 years to go through also. And there is a new command line application or a command line tool in Python, a random number. So if you just want to see the help for that, then random and oh, I should have probably put -- help so it would not stick the error thing at the bottom. But you can give it, say, a choice, an integer or float, and generate random numbers on the command line. A few other little things here and there. A lot of these modules that are not being used by anybody have finally been removed. That's been a PEP, and the removal was scheduled for 3.13, so it got removed. lib 2 to 3 was removed. The porting from Python 2 page was removed. Python 2 is officially gone from the Python 3 docs and from Python 3 in general. Opt-parse and get opt-parse are soft deprecated. Soft deprecation means that you're not supposed to be using them, but there's no timeline for actually pulling them out of the standard library. And there's a variety of other deprecations. As.num, for example, and things like that. There's just a quick list of some developer facing changes. Just to point out, a lot of the things, like it now has an incremental garbage collector, which was important for various reasons, but it won't affect most users. iOS is a supported platform. If anyone's using doc strings, indents are now stripped by the Python compiler, PYC compiler, out of doc strings, which saves space. It can actually save a significant amount of space, like 10% of your PYC file was white space in front of doc strings. But if you are processing them, that's gone now. There's no way to get that white space. Python, if you make a virtual env with Python -m you actually now get a getignore that ignores everything, which is really nice. UV has already been doing this for a while. And a few things, including when I mentioned we have perf support. You can do perf JIT support, which will allow perf to work if you don't have frame pointers enabled, which is apparently pretty rare. So 3.12 could do it with frame pointers. Python 3.13 uses this really cute trick where it basically adds a JIT, and this is a different JIT from the actual JIT, from the enabled, and the JIT that's supposed to make it faster. But it does this so that there are actual names and stuff for everything in Python for perf. You can use this all today. GitHub Actions, just so let's enable allow pre-releases. Mini Linux has these. On Mini Linux and CI build wheel, you can set CI build wheel pre-release Pythons. As a reminder, you won't need that after it becomes ABI stable, like guaranteed ABI stable, which will be either RC1 or technically I think that happens beta 4, but CI build wheel historically sort of waited till RC1. Okay, so one more thing, and that's this three-threaded Python. So Python 3.13 can be compiled without the GIL. So the GIL is the global interpreter lock, and it exists because all objects in Python have a ref count, and almost everything you touch, just looking at a Python variable, generally creates a temporary which touches the ref count. This is used all the time. So it turns out it's really hard to lock just on this ref count, because if you do that, it will really slow down Python a lot, like 10, 20 times. So the way that Python works around it is it just locks whenever the Python interpreter is active. But this, unfortunately, means that only a single Python operation can run at a time, which means that Python doesn't handle multi-core CPUs very well. But not all is lost. And today what we do is, for compiled operations, things like boost histogram and NumPy will release the GIL while they're working. And if they release the GIL, then you can run other Python operations while that long-running C operation is done, while it's being worked on. It's not that hard to remove the GIL, honestly. In fact, the very first patches to remove the GIL started as early as 1.4. The hard thing is to make it fast. Removing the GIL slows things down a ton. I think the very first patch slowed it down like 10 times or something, 10 times slower. So it's very hard to not lose performance. So Sam Gross finally did this, did an amazing amount of work, and it's honestly it's really very, very well done. And here's some of the tricks that are used to make it possible to run relatively quickly without the GIL. Immortal objects are slowly being added, and I got added in 3.12, but there's a slightly modified version when the free threading mode. And it turns out a lot of objects like none, we ref count that in Python because actually adding an if for none instead of just bumping the ref count up and down slows down the interpreter a little bit just because it is such a hot path. You're constantly doing this. But for free-threaded Python, it makes a lot of sense to say, okay, let's bump the ref count as little as possible. So let's make immortal objects. Let's just put an if in there that says don't do anything if it's immortal. And then also there's this concept of nearly immortal. So a ton of objects in Python, like modules, functions, code options, objects, don't get deleted often. So you can actually treat those differently and speed up the ref counting for those with this thing called deferred ref counting. And sort of the key thing that it was built in here is biased ref counts. So all objects in CPython, when you turn on the free threading mode, now have two ref counts. One is a thread local ref count, and one is a shared ref count. And that thread local one, you don't have to lock on because that's local to your thread, and that's the one that tends to get bumped around the most. And then when the garbage collector runs, it just has to stop everything, and then it has to sum up the thread local and shared ref counts, and then operate on that. And then they had to switch allocators. Microsoft had a thread safe allocator, mmalloc, which actually was just about as performant as the pymalloc, which was very impressive because pymalloc was specially designed for these small allocations that Python does all the time. But it's our thread safe. Well, pymalloc was not. So I'm actually very excited about switching that over and actually removing code. So the free threaded build is called Python 3.13t. It's actually not called 3t, just 3.13t for weird reasons. And it does not support the stable ABI. So if you've been building stable ABI, you do have to rebuild for 3.13t. We're in the phase 1 of the plan, so Python 3.13 and probably 3.14, Gil will be opt-out. Hopefully, maybe as early as 3.15. If this goes well, then Gil will become opt-in instead of opt-out, so the T build will sort of become the standard one. Also, there is a proposal to switch to year-based versioning for Python, in which case 3.15 will be called 3.26. They're obviously not going to switch in 3.14 because everybody has to have Python. And then phase 3 will be only no Gil. And this could be abandoned if the compile extension community, if we don't get on board, then this could be abandoned. So let me show you what it looks like to write for free threaded. The examples are here at this link that if you go there. Here's just a little Python example where I'm computing pi by generating values and seeing if they line a circle. This is the single threaded code. This is how you'd write it today. And then if I wanted to write it for free threaded Python, all I need to do is make two changes. One is I have to run it in threads. And the other change I need to do, so if you just do that, you'll notice it actually gets a little bit slower. And the other change I need to do is I need to save the random number generator. Say this makes a new random number generator, and then that's the one I use to generate random numbers. This will get random number. This will be done per thread, which means I'm no longer fighting for a global random number state. So you don't, because if I use this code, this is a global random number state. It is thread safe. It's really nice that they made that thread safe. They're trying to make things work as much as possible, but it does slow things down because now I'll be fighting for a single resource. So if you do this, this is how you would do this in free threaded. Now, historically, you could write this in regular Python, but it will not be faster if you run in threads because you're doing Python operations. However, in free threaded Python, it actually gets faster. This is the time for 1 thread, 2 threads, and then 4 threads. And you can see that it scales quite nicely for doing 10 million bits. You can also do this from compiled code. If you're writing compiled code, this is what the PyBind 11 code would look like. So this is C++. The same thing we're again making a standard number, or making a random number engine inside the function so that it makes sure it's done on your local thread. Um, and then we're just doing the same calculation. And then PyBind 11 module. The new thing here is this. So the most recent version of PyBind 11 added the PyModGil not used. And that's a marker that says that this extension is aware that the GIL may not be there. So it's not going to use the GIL. And then if you want to build this with scikit build core, then this is your CMake file that you would need. You actually don't have to have these 2 lines, but they're a good idea. And then this is your pyproject.toml. So scikit build core and PyBind 11. Build core were built. And if you're going to be using CI build wheel, this is what you need to do this for CI build for CI build wheel. You need to make sure that you turn on the free threaded support option. Otherwise, it will not add these for the free threaded builds for you. Okay. And also, you still need to have this environment variable set. Or you can, if you're running it locally, you can do -- only and then give it the 3.13t expression. Okay. So there's the threading performance for PyBind 11. This is using 100 million instead of 10 million. 2 seconds, 1 second. So it works. So it scales up quite nicely, and we can just sort of where they go. So there is this, if you want to track the progress of this for the scientific Python ecosystem, well, for the entire Python ecosystem, though it's heavily being driven by the scientific Python ecosystem, you can go to this page, this GitHub repository, Quantsite Labs free threaded compatibility. Free threaded compatibility has a description of how you use it, but it also has these tracking issues for all these different projects. So CI build wheel mini Linux are ready, and PyBind 11 is now ready. Scikit build core is ready. Meson, Python, and setup tools are more or less ready. I think there may be a couple of issues there, but I think at least with Meson, Python, but I think they're basically ready. And pip, UV, and build now all support it as well. NumPy, SciPy, and Cython all support it also, but you have to get the nightly wheels. As a reminder, there's this nightly wheels Anaconda channel. So this is hosted at Anaconda, but it's actually PyPI wheels for NumPy, SciPy, and Cython. And if you get those are for NumPy and SciPy have Unix free threading wheels ready for you to try. And Cython has will be Cython 3.1. You can get that from here, which has support for free threading. So, but they're still working on it, I think. And the most recent beta 3, which came out a couple of days ago, has PyMutex. So PyBind 11 will probably switch from standard mutex to PyMutex, which would give it a little bit more performance. And there's reasons to not like standard mutex very much. And PyBegin critical section is now made public as well. So these are part of how Python itself works, but it's really nice to have those available for extension authors too. Beta 3 is in Mini Linux now, and it's coming to CI build probably today or tomorrow. For 3.13 and beyond, this is the sort of plan. You can get the plan from the link that you see there. There's sort of the goal here is to enable more optimizations. Currently, if you switch on free threading mode, single threaded code gets noticeably slower because it's actually supposed to only be a small, like 6 to 8% effect, but it's more than that right now because it turns off a lot of the things that have happened in the last couple of years to make Python 3.11 and 3.12 fast. So things like the specializing adaptive interpreter get turned off when you turn on free threading just because there wasn't time to make it work. But the goal is to sort of make those things work. Okay, and so that's Python 3.13. It's the most forward-thinking version of Python ever. A new REPL that's easier for people to contribute to. It's just Python. It's not tied to the internals. A new JIT, which is hopefully going to make future versions much faster. And 2 forms of parallelism are available. This per interpreter GIL, which extension authors have to also support. I find the free threaded build to be, even though it's a bigger change and it requires a lot of changes to compiled code, like you have to actually compile for the free threaded build. I find that to be a better path just because for per interpreter GIL, you still have to do extra work and it's not quite as clear what that work is. Okay. And so that's what happened.
Thanks so much, Henry. That was pretty comprehensive. We quite a bit over time, so unless there's a very quick question on this. Of course, Harry is totally available on Slack. I can say that if you want to discuss with him further on any technicalities. In any case, is that okay? So in interest of time, then if there's no, okay, then thanks so much again, Henry. This is pretty cool.